Our objective for today, I can solve and graph quadratic equations using intercepts and vertex. Read together, 1, 2, 3. I can solve and graph quadratic equations using intercepts and vertex. Now, for right now, we pretty much know what the whole objective stands for. What is the only word that's new from the objective, everyone? Vertex. So underneath vertex, I want you to do a double arrow, like so. Because the vertex means something in regards to the graph that we're going to do today. What does the vertex mean in regards to our graph? The vertex is what we call the highest or lowest point on our graph. Once again, it's called the highest or the lowest point. Another word that they use for highest is the maximum. Therefore, the lowest point is the what? Minimum. And let's see how that looks. When I graph to a parabola and I see a maximum or a highest point, the parabola is like this. The highest point is right here. That means that's called our vertex, our highest or maximum point. If I graph it and the graph is like this, that means this point right here is our what? Our lowest or minimum point. And that's called again what? The vertex. Okay? Yeah, right now we're just talking about the highest and the lowest point. We're not talking about like dimension or how it opens or anything like that yet. Okay? All right. So with that said, let's get started. We don't need a Fermat model because we already know what the quadratic equations are. Steps, we're going to write those steps together along the way. Let me go to example number 1. All right, so where you're taking notes, turn your paper over to the graph side. Your coordinate planes should be on the right-hand side. Do you guys see them right here? So you're going to copy this example 1 on the top left corner. On the top left corner. I'm showing you right here. The graphs are on the right side. You're going to copy it on the top left. Example number 1. Okay? All right. Copy that. Example number 1. Example 1. Solve and graph the quadratic equation using the vertex, x-intercepts, and y-intercepts. So as you're copying that, you're saying solve. Do I know how to solve? Yes. What do we call the solution to a quadratic equation? The x-intercepts. So that means I need to solve it to get my x-intercepts. Okay. So the only thing I see here that I wouldn't know how to get would be the vertex. And that's what I'm going to show you today. However, I'm going to add one more thing to look at before we go to solve and to graph. But I'll show you that as soon as you're done copying that. Copy that, please. All right? Is everybody done copying? Yeah. Okay, I'm going to get my coordinate plane over here on the right side, just like yours. On the right side, just like yours. Oh, there it is. All right. And I'm going to cover this up for right now. All right. Let me make this a little bit bigger. All right. So I'm going to zoom in, and I need you to follow along, please. Like that, I can go over the process that I need you for. One of the problems for today's home, please, is going to be like this, the entire process. So once again, everybody go like this. Bear with me. Okay, writing utensils down, look up to the screen. Here we go. Focus. So, I'm going to zoom in. They want us to solve this equation, and also they want us to find the vertex and graph. So before I do all that, I know that my first step with any solving any quadratic equation is always what? Standard form and equal to 0. So I'm going to do that really quick, and you're just paying attention. X squared plus 4x minus 5. Okay. So for this kind of problem, I want you, for step number 2, instead of starting to solve, I want us to make predictions in regards to certain things that we can see that are obvious from the graph, from the equation. So look up, please. Here it goes. Step 2, I'm going to make predictions. The first obvious prediction by looking at this equation is that I know what my y-intercept is. Everyone, our y-intercept is what? -5, which is my constant, c. The second thing that's obvious from this is the graph, how it's going to open. If we look at the leading coefficient, if the leading coefficient is a positive, then the parabola will open up, or it's going to make a happy face. If the leading coefficient was negative, well, guess what? It would be what? A frown, and it would be a sad face. So for this prediction is that it's going to open up. Are we there so far? The last, or the third thing I want you to predict is how many solutions are we going to get out of this equation. So here I'm going to write, another word for solutions are roots. I want to find out how many I'm going to get out of this equation. Now, before I do that, let me show you with a graph the possibilities. Ready? Here it goes. Let's say I created my coordinate plane. Here it is. And I'm going to graph a parabola. Ready? Focus. I'm gonna graph my parabola. Focus, please. Here it goes. How many solutions do we have there? Okay, once again. Abraham, how many? Are you sure? No, because you're distracted. Here it goes again. Look at it, everyone. How many solutions? 2. Why? Because those are my what? My x-intercepts. How many x-intercepts do you see? 2. All right, that's one possibility. The other possibility is when it barely touches. How many solutions there? 1. And the third possibility is when it doesn't ever touch the x-axis. How many solutions there? 0. So how many possible solutions? We have none, no solutions, 1 solution, or 2 solutions. Those are the only 3 possible types of solutions that we're going to get. Are we there? So I want to know if my equation is going to give me none, 1, or 2. So here we go. I'm going to go back to where I was. I want to know how many before I get started. Well, I'm going to show you a way of making sure you know how many at the beginning. How do we do that? First, I'm going to write my quadratic formula. X equals minus b plus minus square root b squared minus 4ac over 2a. And you're just paying attention right now. All right, now that I have this, there's a part of this formula that I can use that's going to tell me how many solutions am I going to get. Watch. This part inside of the radical is what we call the discriminant. Discriminant. Who's heard of the word discrimination? Discrimination is when they focus more on one group versus another, or one thing versus another, right? That's why they call this one the discriminant, because we're going to focus on just one thing and finding the solution, not just finding the solution, finding how many solutions. So I'm going to use this part. Once I do that, I write b squared minus 4ac. Pay attention because this is what you're going to be doing tonight. Here it goes. Do we know the value of b? What is it? 4 squared minus 4 times what is a? 1. What is c? Negative 5. And you're just paying attention. I'll let you copy in a little bit. Daniel, a. Here it goes. Let me simplify this. What is 4 squared? 16. What is negative 4 times 1 times negative 5? 20. What is 16 plus 20? 36. Now, that's going to tell me something specific. This is a positive number. So why is that going to tell me how many roots? Well, let me show you. What would be the square root of 36? Or, so it would be plus minus 6. How many solutions? So for this equation, the number he gave me 36, so I'm going to get how many roots? 2 roots. However, what if, you're like, some of you are thinking, well, Mr. Q, what if I plug in numbers and then instead of getting 36, I got negative 36? Well, let's see. What is square root of negative 36? Not 0. Okay, hold on. Question. What is the square root of negative 36? There's no such thing. None. So how many roots am I going to get? None. This one, 2, none. Now, what is the only possibility? So I'm going to write the little table here. The number I get and the roots. Well, let's see. If the number is a positive, how many roots am I going to get? 2. If the number is negative, how many roots am I going to get? None. None. Now, what's the only other possibility aside from positives and negatives? 0. What if the number, when we plug in numbers, we get a 0? What is square root of 0? So how many solutions? 1. What is square root of 0? 0. So is there a solution? Yes, 0, which is 1. So if I get the number 0, there would be 1 root. This is the table that you need in order for you to know how many solutions you're going to get on your prediction. Everybody understand what I did? Copy that, please. So let's see. Step 1, I set it in standard form, equal to 0. Step 2, I only made predictions as to what I wanted to see so I can have a picture, a mental picture of what it looks like. What does it look like? Number 1, it's crossing that negative 5 of y. What else do we know? That it's opening up. And what else do we know? That it's going to cross the x-axis how many times? 2. So those are the 3 things that we know already. Now we're going to get started with the rest of the process. What are they asking us to do to solve? Number 1. Number 2, to find the vertex. So I'm going to start with the vertex because I think that's something important that we need to know. So I'm going to draw a line across like so. And I'm going to write vertex. And what did we say the vertex was? The highest or lowest point. That means I need a coordinate. I need an x value and a y value. So watch. Writing utensils down, look up to the screen. Here it goes. To find the x value of the vertex, I'm going to use another part of the quadratic formula. But I'm going to use this part right here. Do you guys see this? Exactly. I call it the California piece. So I'm going to use this, and I'm going to write it right here. I'm going to change color because I'm over here on the screen and you can't really see that color. I'm going to change color again. And I'm going to write x equals minus b over 2a. All right, now that I have that, do I know what the value of b is from my equation? Yeah. What is that? Okay, here it goes again. Look at the equation. What is a? 1. What is b? 1. And what is C? Okay, so instead of B, I'm going to write 4. Instead of A, I'm going to write 1. This becomes negative 4 over 2, so X is negative 2. It goes right there. Are we there so far? Okay, next. I need a what now? A Y value. Right now I only have an X value. Look at what they gave me originally. Is this, right? What do I do with that? Exactly, we substitute this X value into our original equation. The original equation was Y equals X squared plus 4X minus 5. But now instead of X, what do I write here? Oh my goodness. Negative 2. Negative 2. I'm going to bring down the rest. Y equals negative 2 squared plus 4 times negative 2 minus 5. Y equals negative 2 squared is 4. 4 times negative 2 is negative 8. Bring down the negative 5. From there, Y equals 4 minus 13. What is 4 minus 13? Negative 9. And that goes right there. And what did we just find? The point that's the lowest point on the parabola. Okay? So, copy that, please. I'm going to first scoot up to right there so you know where this came from. And then I'm going to scroll up a little bit once you copy that. Go. Okay, I'm going to move this up. There it is. We can finish copying the rest. So as you're copying that, let's see so far what we have for our graph. We have a y-intercept. Is that true? We have the lowest point on our graph. That's true. What are we missing? The x-intercepts. That is correct. So that means you draw a line across here, and you're going to write x-intercepts. We need to find those. Or in other words, we're going to solve the equation. So I'm going to scroll up a little bit more. And what equation do I write here? 0 equals what? X squared plus 4x minus 5. So far we know 4 different methods to solve. By graphing, by factoring, by completing the square, and using the quadratic formula. Think about it. Which would be the easiest or fastest method to use to find our solution? Vertex. Factoring. Let's use factoring, all right? So at this point, there it is. What goes on top? Negative 5. What goes underneath? 4. What factors of negative 5 add up to 4? Negative 1 and 5. Very good. My goodness. Today hasn't been the day. It's like, I'm like this. Oh, what color is that blue color? Red. There we go. So let's rewrite this one. 0 equals x squared minus 1x plus 5x minus 5. Can we group? Yes, these two, these two. What is GCF for these two? X, we're left with x minus 1. GCF for these two, 5x minus 1. All that equal to 0. Are we done? No. You done with BPP? Yeah, you know me. So we set each, oh, no, I'm sorry. We need to write our factors first. X minus 1 times x plus 5. All that equal to 0. Now we do CPP. X minus 1 equal to 0. X plus 5 equal to 0. Let's solve. I'm going to use red on mine. On yours is going to be neon orange over there on the screen. So I put plus 1, plus 1. X equals 1. Minus 5, minus 5. X equals negative 5. What are these called? These are my solutions. X-intercepts, roots, and zeros. Whew. Let's see all the process so far. Let me zoom out. Look at that. Nice. All right, so now we have our information to start graphing. Here we go. What was the first prediction that we said? The y-intercept. Let's plot that. What is our y-intercept? Negative 5. Negative 5 is down here. Plot your point, please. Focus. Next one. What is our vertex? Negative 2, negative 9. Negative 2, negative 9. What are our roots? 1 and negative 5. 1, bless you, and negative 5. Before you graph your parabola, don't do it yet. I'm going to show you one more thing. Okay, I'm going to zoom into my graph really quick. Focus, please. Writing your utensils down, look up. So watch. Now that we have all this information, pay attention, look up. Let's see. Do we know the y-intercept? Yes. Do we know the roots? Yes. And what was new? The vertex. The vertex also gives us something very specific for us to use. Oh my goodness. Okay, write your utensils down, look up to the screen. The vertex gives us something very specific. The vertex gives us an invisible vertical line. Vertex, vertical line. Let me draw that. Here goes the invisible vertical line. Oh my goodness. Okay, think back to when you were like 2 or 3 that used to watch Barney and all that. Imagine it. Oh my goodness. All right, here we go. So, focus please. So the vertex creates a line. This line right here is an imaginary line. This line has a specific name. It's called a line of symmetry, or also known as axes of symmetry. Now, what does that mean? It means that gives us a balance of what we have. You're saying, what does that mean, Mr. Q? It becomes a mirror. So, for those of you that in the morning you get in front of the mirror, some of you more time than others, guess what? The distance of you, pay attention to this part. The distance that you are physically from the mirror is the same distance of your image in the mirror to the mirror. Okay, here it goes. I'm gonna explain it over here because some of you are like somewhere else. Here it goes. Here's my mirror. This is the line of symmetry. And what this is saying that these points on this side will reflect on this side. Let's see if it's true. How many steps is this point from the line of symmetry? 1, 2, 3. Therefore, obviously, there must be a point reflected 3 steps to this side. So, if that's true, that means, look at our y-intercept. How many steps is the y-intercept from the line of symmetry? 2. Then obviously, in theory, there should be another point reflected on the other side. So you never the coordinate of that point. That is correct. -4, -5. I want you to place a point there. -4, -5. Now we have a very symmetrical parabola. We have the same points on one side, then the other side. Now we can graph our parallel. Here we go. Start from the top left to that point. Get to the vertex. As soon as you get the vertex, come back up through that point, and pardon my, let's see if I can change this. Hold on. There it is. Let me zoom out. And what that gives us is a perfectly symmetrical parabola. So for tonight's home play, check this out. Tonight's home play, is on page 617. You're only going to do the odds only. However, for number 27, I want you to do like this, the entire process. So what do I want for number 27? I want you to do predictions, all this. I want you to find me the vertex. I want you to find me the roots. Pay attention, I'm not done. I want you to plot your points. I want you to sketch your line of symmetry. And I want you to have the same amount of points on one side than the other side. So what does that mean? If you're missing a point, guess what? You're going to have to find it with the line of symmetry. Everybody with me? Yeah. Whatever you do to one side, you do to the other. I'll stop right there. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.